Tonight, we step into a journey that quietly dismantles everything we think we know about our place in the universe. Not through spectacle. Not through shock. But through scale. Because there are truths so large that they do not announce themselves loudly. They do not overwhelm us with drama. Instead, they stretch beyond the limits of our intuition, dissolving our assumptions one by one until we are left standing in a silence that feels almost uncomfortable. Tonight, we explore the true scale of the Andromeda Galaxy. Not as a list of statistics. Not as abstract numbers. But as a lived reality, one that forces the human mind to confront distances, times, and structures so vast that our everyday sense of meaning begins to bend. By the end of this journey, Andromeda will no longer be a faint smudge in the sky or a distant neighbor mentioned in textbooks. It will become a physical place in your imagination. A colossal system of matter and motion. Ancient beyond comprehension, quietly drifting through the cosmic dark while civilizations rise and fall in the blink of an eye. Before we move outward into the unimaginable, we begin with something grounding. Something almost intimate. You can find Andromeda with your own eyes. On a clear, moonless night, far from the glow of city lights, you do not need a telescope or advanced equipment. You need only patience, darkness, and a willingness to look carefully. Against the velvet backdrop of the sky, Andromeda appears not as a brilliant beacon, but as a soft, elongated blur, a faint oval smudge suspended among the stars. It rests within the constellation that shares its name, Andromeda, a figure drawn from ancient Greek mythology. The constellation itself tells a story of vulnerability and endurance, of a princess chained to a rock, awaiting a fate decided by forces far larger than herself. It is a fitting metaphor. To locate it, your eyes first find Cassiopeia, the unmistakable W-shaped constellation. From the center of that celestial zigzag, you trace an imaginary line toward Pegasus. About halfway along that path, the faint patch reveals itself. That is Andromeda. To the naked eye, under truly dark skies, it spans roughly 1.5 to 2 degrees across the sky, the width of 2 or 3 full moons placed side by side. Even then, what you are seeing is only the bright heart of something far larger. Long exposure photographs reveal the truth that human vision cannot. When ultraviolet light and hydrogen alpha emissions are captured, the galaxy stretches outward dramatically. Its full disk spans 5 to 6 degrees across the sky, 10 to 12 full moons in a row, making it the largest deep sky object visible from Earth without magnification. The commonly repeated claim that Andromeda spans 30 full moons arose from older misunderstandings. The reality is more precise, but no less staggering. What matters is not the exact number, but the implication, a single galaxy so large that it dominates the sky, yet appears to us as a ghostly whisper. Ancient observers noticed this whisper long before modern astronomy gave it a name. In the year 964, the Persian astronomer Abd al-Rahman al-Sufi described Andromeda as a small cloud. Chinese astronomers recorded it centuries earlier. They could not have known what they were truly seeing. For over 1,000 years, Andromeda was assumed to be a nebula, a cloud of gas drifting somewhere within our own stellar system. The idea that it might be something far more distant was, for most of history, inconceivable. It was not until the early 20th century that this illusion finally shattered. In the 1920s, Edwin Hubble used the 100-inch telescope at Mount Wilson Observatory to resolve individual stars within the fuzzy patch. Among them were Cepheid variable stars, stars whose rhythmic pulsations reveal their true luminosity. By comparing how bright they appeared to how bright they truly were, Hubble calculated their distance. What he discovered changed everything. Andromeda was not a cloud within the Milky Way. It was an entire galaxy of stars, a structure comparable to our own, lying far beyond the boundaries of our home. The universe, in an instant, became unimaginably larger. Andromeda sits approximately 2.54 million light-years from Earth. This number is often repeated, but rarely understood. A light-year is not a measure of time. It is a measure of distance, the distance light travels in a year. Light moves at roughly 300,000 kilometers per second, the fastest speed permitted by the laws of physics. In 1 year, it covers about 9.5 trillion kilometers. Now multiply that distance by 2.54 million. The result is approximately 24 quintillion kilometers. A number so large that it resists intuition. Sunlight takes just over 8 minutes to reach Earth. If the sun vanished without warning, we would continue basking in its warmth for those final minutes, unaware that it was already gone. Light from Proxima Centauri, the nearest star, beyond our sun, takes over 4 years to reach us. Light from Andromeda takes more than 2 million years. When you look at Andromeda tonight, you are not seeing it as it is. You are seeing it as it was when early human ancestors were first shaping stone tools. When Homo habilis walked the African savannas. When modern humans did not yet exist. All of recorded human history, every city, every empire, every war, every idea, occupies less than 1/4% of the time that light from Andromeda has been traveling toward your eyes. Even at light speed, the fastest travel theoretically possible, a journey to Andromeda would take 2.5 million years. The fastest spacecraft humanity has ever built, the Parker Solar Probe, reaches speeds of about 700,000 kilometers per hour. At that speed, reaching Andromeda would take nearly 4 billion years, roughly the age of Earth itself. Voyager 1, humanity's most distant emissary, would take over 44 billion years to arrive. Longer than the current age of the universe. Andromeda is not just distant. It is profoundly, almost philosophically, unreachable. Yet despite this distance, it is moving toward us. Slowly. Inexorably. Pulled by gravity across the cosmic void. But before we follow that future, we must understand what Andromeda actually is. Not as a dot. Not as an image. But as a structure. Andromeda is a barred spiral galaxy, a vast rotating system with a dense central bar of stars and sweeping spiral arms extending outward. In this respect, it resembles the Milky Way. But in nearly every measurable sense, it is larger. Its diameter stretches roughly 220,000 light-years from edge to edge. Even traveling at the speed of light, crossing it would take longer than modern humans have existed. The Milky Way spans about 100,000 light-years. Andromeda is roughly 1.5 times wider. Within this enormous disk reside approximately 1 trillion stars. Each star is a sun. Each sun may host planets. Each planet carries the possibility, however remote, of its own story. If you began counting Andromeda's stars at a rate of 1 per second, without stopping to eat or sleep, it would take more than 32,000 years to finish. Longer than all of recorded civilization. And this is only the beginning. And this is only the beginning. At the very heart of Andromeda lies a region so dense, so ancient, that it represents a completely different mode of existence compared to the calm, sparse neighborhood we call home. The central bulge of Andromeda spans nearly 30,000 light-years across, almost 1/3 the entire diameter of the Milky Way. Within this volume reside several hundred billion stars, packed together at densities thousands of times greater than those near our Sun. Here, space does not feel empty. If you could somehow stand on a planet orbiting a star near Andromeda's core, assuming such a planet could survive, your night sky would never truly grow dark. Thousands of stars would blaze brightly enough to cast shadows. The combined glow would create a permanent twilight, erasing the distinction between night and day. Darkness, as we understand it, would be impossible. Most of these stars belong to an older generation. Astronomers call them population 2 stars, ancient suns formed when the galaxy was young and the universe had not yet been enriched with heavy elements. In astronomical language, they are metal poor, meaning they contain relatively little carbon, oxygen, iron, and other elements forged later in stellar furnaces. They glow predominantly in warm reds and oranges. Red giants dominate the scene. Stars that have exhausted the hydrogen in their cores and swollen to enormous sizes. Some of them are so vast that, if placed at the center of our solar system, they would engulf the orbit of Earth and stretch beyond Mars. The density of stars near the core creates an environment unlike anything in our galactic suburbs. Stars pass close enough to one another that gravitational encounters are common. Binary systems are disrupted. Stars are exchanged between partners. Some are slingshot outward at tremendous speeds, ejected into the halo or even beyond the galaxy itself. Occasionally, a star wanders too close to the central supermassive black hole. At Andromeda's core resides a black hole with a mass of roughly 140 million times that of the Sun, about 35 times more massive than Sagittarius A*, the black hole anchoring the Milky Way. For years, astronomers debated whether Andromeda might contain 2 supermassive black holes. Images revealed a curious double structure at the galaxy's center, and theories flourished. But modern observations have largely resolved the mystery. The apparent duplication is not 2 black holes, but a single black hole, surrounded by an eccentric, elongated disk of stars. Their orbits create a striking optical illusion, a reminder that even our best images can mislead intuition. When a star drifts too close to this black hole, tidal forces tear it apart. The star is stretched into a long stream of glowing gas in what astronomers call a tidal disruption event. The gas spirals inward, heating to millions of degrees, emitting powerful X-rays before vanishing beyond the event horizon. For now, Andromeda's black hole is relatively quiet. It is not actively feeding at high rates. But this calm is not permanent. If a large gas cloud, or an unlucky star, were to fall inward, the black hole would flare to life. A swirling accretion disk would form, emitting more energy than the rest of the galaxy combined. Jets of particles might erupt from its poles at nearly the speed of light, transforming Andromeda into a blazing quasar visible across the universe. This is the paradox of galactic centers. They appear serene. They are anything but. Moving outward from the bulge, the galaxy opens into its most iconic structure, the spiral arms. These arms are not rigid structures. They are not permanent features made of fixed stars. Instead, they are density waves, slow-moving compressions that ripple through the galactic disk. A useful analogy is traffic on a circular highway. Cars move forward, but traffic jams form and dissolve. The jam itself travels at a different speed than the cars within it. Spiral arms behave the same way. Stars and gas pass through the arms, lingering briefly before moving on. The arms shine brightly because they are sites of creation. As density waves compress clouds of cold gas, gravity gains the upper hand. Clouds fragment. New stars ignite. Massive O and B-type stars are born, luminous giants that burn through their fuel in just a few million years. They shine thousands or even millions of times brighter than the sun, bathing their surroundings in ultraviolet light. But these stars live fast and die young. Before they have time to drift far from their birthplaces, they explode as supernovae. Their death seed the surrounding space with heavy elements, shock waves, and energy. This is why the spiral arms glow blue and ultraviolet, while the rest of the disk appears older and redder. Andromeda's spiral pattern is not perfectly symmetrical. One side appears stronger, more pronounced than the other. This imbalance is a scar, a remnant of violence. roughly 800 million years ago. Andromeda experienced a major collision with another large galaxy. The impact disrupted its orderly structure, warping its disk and leaving behind asymmetries that persist today. Galaxies remember their trauma. Computer simulations show that it can take billions of years for a disturbed galaxy to relax back into symmetry. Andromeda is still healing. Embedded within the spiral arms lie immense molecular clouds, the coldest, densest structures in the galaxy. These clouds can span hundreds of light years and contain enough material to form millions of stars. They are composed primarily of molecular hydrogen, along with carbon monoxide, ammonia, and more complex organic molecules. Dust grains mixed into the gas play a crucial role. They provide surfaces where molecules can form and shield the interiors of clouds from destructive radiation. To visible light, these clouds appear as dark silhouettes, blocking starlight. But infrared telescopes reveal glowing cocoons, where new suns are quietly assembling. Star formation in Andromeda is not evenly distributed. There is a prominent ring of enhanced activity about 32,000 light-years from the galaxy's center. In ultraviolet images, this ring blazes with clusters of young, hot stars. Its origin is likely tied to the galaxy's central bar, which channels gas inward and outward, creating resonances where material accumulates and collapses. Within this ring, thousands of stellar nurseries are active right now. Each one is a cradle for future solar systems. The disk itself is remarkably flat, about 1,000 light-years thick, shaped by rotation. As Andromeda formed, random motions of gas collided and cancelled out, but angular momentum could not be erased. The result was a rotating disk, flattened like spinning dough. Yet this disk does not rotate like a solid object. Stars near the center complete an orbit in tens of millions of years. Farther out, orbital periods stretch into hundreds of millions or even over 1 billion years. This differential rotation should, in theory, wind the spiral arms tighter and tighter over time. But they persist because they are not material structures, but waves. By measuring how fast stars orbit at different distances, astronomers uncovered another profound truth. The visible matter in Andromeda, all its stars, gas, and dust, cannot account for the observed rotation speeds. Stars far from the center move much faster than gravity from visible matter alone would allow. Something unseen is holding the galaxy together. This invisible mass is dark matter. It dominates Andromeda's mass budget, outweighing normal matter by roughly 6 to 1. It forms an enormous halo extending hundreds of thousands of light-years beyond the visible disk. Without dark matter, Andromeda could not exist in its current form. It provides the gravitational scaffolding upon which the galaxy is built. Here, we encounter one of the deepest mysteries in modern physics. We do not know what dark matter is. It does not emit light. It does not absorb light. It does not interact electromagnetically at all. We know it exists only because of its gravitational influence. It bends the motion of stars, warps space itself, and shapes the large-scale structure of the universe. In a very real sense, everything we can see floats within an ocean of something we cannot. Understanding Andromeda requires understanding time on scales that dwarf human experience. Galaxies evolve slowly. Changes unfold over millions and billions of years. To a human lifetime, Andromeda appears frozen, eternal. But this stillness is an illusion. Right now, Andromeda forms about 1 solar mass worth of new stars each year. At the same time, stars are dying. Supernovae erupt. White dwarfs cool. Black holes grow. The balance is shifting. Andromeda is aging. Its star formation rate is lower than in its youth. The average age of its stars is slowly increasing. Over cosmic time, it is transitioning from a vibrant, star-forming spiral toward a quieter, more quiescent future. And all the while, Andromeda is moving. It is approaching the Milky Way at roughly 110 kilometers per second. This speed is immense by human standards. Yet across a gulf of 2.5 million light-years, the motion feels glacial. Each million years, the distance shrinks by only about 100 light-years. Still, the approach is inevitable. Gravity never forgets. Gravity never forgets. To understand why Andromeda's approach toward us is not a matter of speculation but of certainty, we must understand how humans measure distance across a universe that refuses to be measured directly. You cannot aim a laser at Andromeda and wait for the reflection. The distance is too vast. Instead, astronomy relies on a delicate chain of methods known as the cosmic distance ladder. Each rung extends our reach a little farther, built upon the reliability of the one below it. If any rung is unstable, everything above it collapses. The lowest rung begins close to home. Within the solar system, distances can be measured directly using radar. A radio pulse is sent toward a planet or moon, and the time it takes to bounce back reveals the distance with extraordinary precision. These measurements define the astronomical unit, the average distance between Earth and the Sun, about 150 million kilometers. From this baseline, geometry takes over. As Earth orbits the Sun, nearby stars appear to shift slightly against the background of more distant ones. This apparent motion, called parallax, is tiny but measurable. Using simple trigonometry, astronomers can calculate stellar distances. The European Space Agency's Hipparcos satellite, and later Gaia, have measured parallaxes for billions of stars, mapping our galaxy in unprecedented detail. But parallax has limits. Beyond a few thousand light-years, the shifts become too small to detect. To go farther, astronomers turn to objects whose true brightness is known: standard candles. A standard candle works like a light bulb of known wattage. If you know how bright it truly is and how dim it appears, distance follows naturally. The most important standard candles for nearby galaxies are Cepheid variable stars. These stars pulse rhythmically, growing brighter and dimmer over predictable cycles. In 1912, Henrietta Swan Leavitt made a discovery that changed astronomy forever. The period of a Cepheid's pulsation is directly related to its true luminosity. Measure the rhythm, and you know the power. Edwin Hubble used Cepheid variables to measure the distance to Andromeda in the 1920s. Though his early estimate was low due to unknown complexities, it was sufficient to prove a revolutionary truth: Andromeda lay far beyond the Milky Way. Modern measurements, using the Hubble Space Telescope and refined calibrations, place Andromeda at 2.54 million light-years, with uncertainties of only a few percent. Beyond Andromeda, astronomers climb higher on the ladder. Type Ia supernovae, exploding white dwarfs, serve as even brighter standard candles. Their peak brightness is remarkably consistent, allowing distances to be measured across billions of light-years. By calibrating these explosions using galaxies like Andromeda, astronomers discovered that the universe's expansion is accelerating, a finding that reshaped cosmology and earned a Nobel Prize. In this way, Andromeda occupies a critical rung in humanity's understanding of the cosmos. It is close enough to measure precisely, yet distant enough to anchor our grasp of the vast universe beyond. To understand Andromeda, however, we must also understand the lives of its stars. Stars are not eternal. They are born, they live, and they die. Their life stories determine the appearance, chemistry, and future of the galaxy itself. Stars form in molecular clouds when gravity overcomes internal pressure. As a cloud collapses, it heats up. When the core temperature reaches about 10 million degrees, hydrogen fusion ignites. A star is born. From that moment, mass dictates destiny. Small stars, red dwarfs with less than 40% of the sun's mass, burn their fuel slowly and efficiently. They can live for trillions of years, far longer than the current age of the universe. Every red dwarf that has ever formed is still shining today. These stars dominate Andromeda numerically, though their faint light contributes little to the galaxy's overall glow. Stars like our Sun live for billions of years. They fuse hydrogen steadily, maintaining a delicate balance between gravity and pressure. After exhausting their core hydrogen, they swell into red giants, shedding their outer layers as planetary nebulae and leaving behind white dwarfs, dense stellar embers that cool over trillions of years. Massive stars live dramatically different lives. Born with more than 8 times the sun's mass, they burn furiously, shining millions of times brighter. Their lives last only millions of years. When their cores collapse, they explode as supernovae, briefly outshining entire galaxies. The explosion scatters heavy elements into space, enriching the galaxy and seeding future generations of stars and planets. Right now, in Andromeda, every stage of stellar life is unfolding simultaneously. Red dwarfs are forming. Sun-like stars are shining steadily. Red giants are swelling. Planetary nebulae are expanding. Supernovae are erupting. Each supernova releases as much energy in weeks as the sun will emit over its entire 10 billion-year lifetime. These explosions drive galactic winds, heat the interstellar medium, and can trigger new star formation. Through this cycle, Andromeda's chemistry evolves. The earliest stars formed from primordial hydrogen and helium. When they died, they returned carbon, oxygen, and heavier elements to space. Over billions of years, the galaxy became enriched. Today's stars contain enough heavy elements to form rocky planets, and potentially life. Binary stars add further complexity. In many systems, stars exchange mass. White dwarfs can steal material from companions. If enough mass accumulates, the white dwarf ignites catastrophically, producing a Type Ia supernova. These events are rare, but essential, both for enriching galaxies and for measuring the universe. Beyond stars and gas, Andromeda is threaded with invisible forces. Magnetic fields spiral through the galaxy, generated by the motion of ionized gas. Though weak by everyday standards, they exert profound influence across vast distances. They guide charged particles, help support gas clouds, and shape star formation. Cosmic rays, high-energy particles accelerated by supernova shocks, race through the galaxy at nearly the speed of light. Confined by magnetic fields, they contribute energy and pressure to the interstellar medium. When they collide with gas, they produce gamma rays, revealing their presence to space-based observatories. Seen in radio wavelengths, Andromeda glows with synchrotron emission from these cosmic particles, tracing the spiral. Arms and magnetic structures invisible to optical eyes. The galaxy is not merely a collection of stars. It is a dynamic ecosystem of matter, energy, and time. Between the stars lies the interstellar medium, a thin mixture of gas and dust filling the spaces between suns. Hydrogen exists in multiple forms: cold molecular clouds, warm atomic gas, and hot ionized regions glowing around young stars. Dust, though only about 1% of the mass, plays an outsized role. It absorbs and scatters starlight, hides star formation from view, and provides surfaces for molecules to form. Without dust, chemistry, and life itself, would be impossible. Infrared observations reveal Andromeda's hidden structure. Warm dust outlines spiral arms. Cold dust maps star-forming rings. Regions invisible in visible light emerge clearly in infrared glow. Beyond the bright disk lies a realm few ever imagine. The halo. Andromeda's stellar halo extends at least 500,000 light-years from the center, far beyond the visible galaxy. It contains only about 1% of the stars, but spread across such a vast volume that stellar densities are extraordinarily low. Here, the nearest star might be hundreds of light-years away. The sky would be almost completely dark, except for the brilliant core of Andromeda dominating one region like a distant cosmic sunrise. The halo is not smooth. It is littered with stellar streams, the shredded remains of smaller galaxies torn apart by Andromeda's gravity. Each stream traces the orbit of a lost companion. A fossil record of galactic cannibalism. Deep surveys have revealed dozens of these streams, shells, and overdensities. Each one tells a story of growth through destruction. Andromeda has grown. Large by consuming others. And it is not finished. And it is not finished. Surrounding Andromeda like a swarm of fireflies frozen in time are its globular clusters, some of the oldest structures in the universe. These are dense, spherical assemblies of stars, each containing tens of thousands to millions of suns packed into a region only a few dozen light-years across. Andromeda possesses over 500 known globular clusters, far more than the Milky Way's roughly 150. Many of them formed more than 12 billion years ago, when the universe itself was young. Others were acquired later, stolen from smaller galaxies that Andromeda consumed over cosmic time. Inside a globular cluster, the environment is extreme. Stars are separated by mere fractions of a light-year. Stellar encounters are common. Binary systems form, break, and reform. Blue stragglers, stars that appear younger and hotter than they should be, emerge through mergers and mass transfer, defying simple stellar evolution. If life were to arise in such a cluster, its night sky would be breathtaking and dangerous. Stellar flybys could destabilize planetary orbits. Radiation levels would be higher. Stability would be rare. Yet globular clusters serve as cosmic time capsules. By studying their stars, astronomers reconstruct the early chemical history of Andromeda, revealing when and how the galaxy assembled. Beyond the clusters lie Andromeda's satellite galaxies. Dozens of small dwarf galaxies orbit Andromeda, bound by gravity like moths around a flame. Some are irregular, chaotic systems rich in gas and star formation. Others are spheroidal, gas-poor remnants, galaxies that have been stripped of their ability to form new stars. Among the most prominent satellites are M32 and M110. M32 is compact and unusually dense. Its structure suggests it was once a larger galaxy whose outer layers were torn away by Andromeda's tidal forces, leaving behind a naked core. It may harbor its own central black hole, making it a miniature echo of its massive host. M110, by contrast, is more diffuse. It contains older stars and shows signs of prolonged interaction, its shape distorted by Andromeda's gravity. These satellites are not merely companions. They are food. Over billions of years, dynamical friction causes their orbits to decay. They spiral inward, stretched and shredded, their stars redistributed into Andromeda's halo. Gas is stripped and funneled into the disk, fueling new generations of stars. This process is ongoing. Astronomers can identify streams from disrupted satellites still in the act of being absorbed. Some of these streams are so faint that they were invisible until the most sensitive surveys mapped the sky in exquisite detail. Galaxies grow by eating. This is not an exception. It is the rule. Zooming out even farther, Andromeda does not exist in isolation. It is the dominant member of the local group, a gravitationally bound collection of more than 50 galaxies spanning roughly 10 million light-years. Along with the Milky Way and the smaller Triangulum galaxy, Andromeda shapes the dynamics of this entire region of space. The local group is not expanding with the universe. Gravity has overcome cosmic expansion here. These galaxies are bound together, destined to interact and merge over time. Andromeda's approach toward the Milky Way is the most dramatic expression of this fate. Measurements of Andromeda's radial velocity show it is moving toward us at about 110 kilometers per second. For years, astronomers debated whether it might simply pass by, missing us due to sideways motion. But precise observations from the Hubble Space Telescope and Gaia have largely settled the question. The sideways, or tangential, velocity is small. The collision is coming. In approximately 4 to 5 billion years, Andromeda and the Milky Way will begin their first close encounter. The word collision is misleading. Galaxies are mostly empty space. The chance of individual stars colliding is vanishingly small. But gravitational interactions will be profound. Tidal forces will distort both galaxies, stretching out long tails of stars and gas. As they approach, their spiral structures will unravel. Star formation will surge as gas clouds collide and compress. Supernova rates will spike. The night skies of any surviving planets will change beyond recognition. From Earth's perspective, if Earth still exists, Andromeda will no longer be a faint smudge. It will grow larger each night, its spiral arms stretching across the sky, dominating the heavens like a cosmic tide. After the first pass, the galaxies will separate, only to fall back together again. This dance may repeat several times over billions of years. Eventually, they will merge into a single, massive galaxy, often nicknamed Milky Way. The final product will likely be an elliptical galaxy, rounder, redder, and quieter than the spirals that birthed it. Star formation will dwindle as gas is consumed or expelled. The central black holes will spiral together and merge, releasing tremendous energy in gravitational waves that ripple across spacetime. For any remaining observers, the sky will be unrecognizable. Constellations will dissolve. Familiar patterns will be gone. The concept of a stable night sky will become meaningless. Yet this future lies far beyond any human timescale. Long before Andromeda arrives, Earth will face its own challenges. The sun will grow brighter, rendering the planet uninhabitable within 1 billion years. Oceans will evaporate. Life, if it persists, will adapt or migrate. Perhaps beyond Earth entirely. In this sense, the Andromeda collision is not a threat. It is a reminder. A reminder that change is the only constant on cosmic scales. As we contemplate this future, our perspective shifts. Human lives are measured in decades. Civilizations in millennia. Even species rarely endure beyond a few million years. Against this backdrop, galaxies evolve slowly. Majestically, indifferent to the brief sparks of consciousness that arise within them. And yet, here we are. Tiny beings on a small planet, capable of understanding a galaxy millions of light years away. Capable of reconstructing its past and predicting its future. This is perhaps the most astonishing fact of all. The atoms in our bodies were forged in stars, some of them in galaxies like Andromeda. Carbon, oxygen, iron, the elements of life, were scattered by supernovae long before the Sun existed. In a very real sense, Andromeda is not foreign. It is family. When we look at Andromeda, we are looking at a mirror, not of our present, but of our cosmic ancestry. We see what galaxies become. We see where we are going. And we are forced to confront a deeper question. What does it mean to exist in a universe so vast that even our grandest futures are temporary? Perhaps meaning does not come from permanence. Perhaps it comes from awareness. From the fact that the universe has produced, at least in this corner of space and time, beings capable of asking these questions. Beings who can look at a faint smudge in the sky and understand it as 1 trillion suns. Bound together by gravity and time. Andromeda does not care that we observe it. But we care. And in caring, in seeking to understand, we carve out a fragile but profound place within the cosmos. Perhaps meaning does not come from permanence. Perhaps it emerges from the brief moment in which the universe becomes aware of itself. Time, on cosmic scales, behaves in ways that defy human instinct. We are shaped by seconds and years, by deadlines and lifespans. But galaxies live in epochs. Their clocks tick in millions of years. Their memories are written not in words, but in orbits, chemical compositions, and the faint scars of ancient collisions. Andromeda is not a snapshot. It is a process. Every photon reaching your eyes tonight began its journey before modern humans existed. In that sense, observation itself is an act of time travel. You are not seeing Andromeda now. You are seeing a version of it that no longer exists, a configuration of stars and gas already subtly altered by gravity, motion, and decay. The present, at cosmic scales, is always inaccessible. This raises a quiet but unsettling realization. There is no universal, now. Events that feel simultaneous to us are separated by millions of years elsewhere. Cause and effect stretch across incomprehensible distances. What we call reality is a thin slice through a four-dimensional structure, where time and space are inseparably woven. Andromeda exists not just across space, but across time. Its oldest stars formed more than 12 billion years ago, when the universe was less than 10% of its current age. Back then, galaxies were smaller, messier, and far more violent. Gas was abundant. Collisions were frequent. Supermassive black holes grew rapidly, blazing as quasars. Andromeda has survived all of this. It has endured the reionization of the universe, when the first stars flooded space with ultraviolet light. It has weathered countless mergers, absorbed smaller galaxies, and reshaped itself again and again. In contrast, humanity has existed for roughly 300,000 years. If Andromeda's life were compressed into a single calendar year, modern humans would appear in the final second before midnight on December 31st. Recorded history would occupy less than the blink of an eye. This imbalance can feel humbling, even diminishing. But it can also be liberating. Because significance does not scale with size. A thought does not need to be ancient to be meaningful. A moment does not need to last forever to matter. Andromeda's vastness does not erase human experience. It contextualizes it. Consider the fragility of structure. Galaxies feel eternal to us, but they are temporary. Over tens of billions of years, star formation will cease. Gas will be exhausted or expelled. Stars will fade into white dwarfs, neutron stars, and black holes. Eventually, even galaxies will dissolve. Gravitational interactions will fling stars into intergalactic space. Black holes will merge and then, over unimaginably long timescales, evaporate through Hawking radiation. The universe will grow darker, colder, and more dilute. This is not speculation. It is the natural consequence of known physical laws. Andromeda's destiny, like ours, is impermanence. Yet within this impermanence lies a remarkable fact. For a brief window of cosmic history, conditions exist that allow complexity to arise. Atoms assemble into molecules. Molecules into cells. Cells into minds capable of reflection. This window is narrow. Too early, and the universe is too hot, too chaotic. Too late, and energy gradients fade, leaving no fuel for complexity. We live near the peak of this window, a fleeting era when stars still shine brightly and heavy elements are abundant. Andromeda shines during this same window. Across the gulf of space, two galaxies evolve in parallel, each hosting countless stars, planets, and perhaps forms of life utterly unlike our own. The probability is unknown. We do not know how common life is. We do not know how often intelligence arises. We do not know whether consciousness is rare or inevitable given the right conditions. But Andromeda contains roughly 1 trillion stars. Even if life is extraordinarily rare, 1 planet in a billion, that would still imply thousands of living worlds within that single galaxy. Some may be simple. Some may be complex. Some may be extinct. Some may be just beginning. If intelligent beings exist there, they would look back at us and see the Milky Way as it was millions of years ago. They would not see cities or technology. They would see a quiet spiral galaxy, unaware of the thoughts unfolding within it. Civilizations could rise and fall there without ever knowing we existed. Distance is not just spatial. It is epistemic. There are truths separated from us not by hostility, but by scale. And yet, Andromeda is not unreachable in every sense. Though we may never travel there, we have already reached it with understanding. We have mapped its structure. We have measured its motion. We have reconstructed its past and predicted its future. This is the quiet power of science. Without leaving our planet, we extend our minds across millions of light years. We decode ancient light. We infer invisible matter. We listen to the echoes of cosmic events that happened long before Earth formed. In doing so, we transcend, briefly, the limitations of our biology. But understanding alone is not the end of the story. There is an emotional dimension to scale. Standing beneath a dark sky, seeing Andromeda with the naked eye, something shifts. The galaxy does not feel abstract. It feels present. A soft glow, ancient and patient, reminding us that reality extends far beyond our concerns. Some experience awe. Some feel insignificance. Some feel connection. All are valid. Awe, in particular, plays a crucial role in human psychology. It expands perception. It quiets ego. It fosters curiosity and humility. Studies show that moments of awe can make people more cooperative, more reflective, and more open to new ideas. In this sense, Andromeda is not just an object of study. It is an experience. It invites us to step outside the narrow bandwidth of everyday life and glimpse a larger narrative, one that does not revolve around us, but still includes us. The danger lies not in recognizing our smallness, but in forgetting our uniqueness. The universe may be vast, but it is not crowded with meaning. Meaning arises where minds arise, where questions are asked, where patterns are recognized and interpreted. Andromeda does not ask questions. We do. And that distinction matters. As Andromeda continues its slow approach, indifferent to human calendars, it carries with it the accumulated history of billions of years. When it finally merges with the Milky Way, long after humanity's fate has been decided, the resulting galaxy will carry traces of both. Stars from Andromeda will mingle with stars born around our Sun. Their orbits will intertwine. Their elements will mix. In a poetic sense, our galaxy and Andromeda are already connected. They are bound by gravity, by shared origin, and by a future written into the fabric of spacetime. We are temporary witnesses to this process. And that may be enough. To exist briefly, to know that we exist, and to glimpse the grand structures that cradle our moment in time, this may be the closest thing to purpose the universe offers freely. Andromeda does not give us answers. It gives us perspective. A reminder that we are small, but not meaningless. Brief, but not irrelevant. Local, but capable of understanding the universal. In the end, perhaps the true scale of Andromeda is not measured in light years or star counts. Perhaps it is measured in what it does to the human mind when we finally allow ourselves to see it not as a dot, but as a living, evolving presence in the cosmos. A presence that has been there long before us. A presence that will endure long after. And a presence that, for a fleeting moment, we are able to comprehend. We can let the ending breathe longer. Not by adding new facts, but by slowing time itself, stretching the final moments so the listener does not feel the story stop, but gently dissolve. Because the universe never ends abruptly. It fades. Imagine, once more, standing beneath a truly dark sky. No artificial lights. No notifications. No sense of urgency. Just the quiet rotation of Earth and the slow drift of stars. Your eyes adjust. Familiar. Constellations emerge. And then, almost reluctantly, Andromeda appears again, faint, elongated, easy to miss unless you know where to look. It does not announce itself. It waits. That faint glow is not dramatic because drama is a human invention. Andromeda has no need to impress. Its existence alone is enough. A trillion suns bound together, moving as one. Tracing an arc through spacetime that began long before Earth cooled. The longer you stare, the more unsettling the realization becomes. Everything in your life has changed faster than that light has traveled. Every joy you've known. Every loss you've endured. Every version of yourself you've ever been. All of it unfolded while that ancient light was already on its way. In that sense, Andromeda has been with you your entire life, and the lives of everyone who came before you. Its photons brushed past Earth long before your name existed, long before language, long before memory. And still, they arrive. This continuity is rare. Most things we know are transient. Relationships change. Bodies age. Civilizations rise and fall. But Andromeda offers a counterpoint, not permanence, but persistence. A reminder that some processes unfold so slowly that they feel eternal to creatures like us. Yet even this persistence has limits. One day, far in the future, the night sky will no longer look like this. Not because Andromeda will vanish, but because expansion will carry distant galaxies beyond our observable horizon. Their light will stretch, redden, and fade until it can no longer reach us. Future astronomers, if any exist, may look out into a sky almost empty of galaxies. They may not know Andromeda ever existed unless records survive. The universe forgets easily. Memory, it turns out, is a fragile thing. Which makes this moment, now, strangely precious. We live at a time when Andromeda is visible. When the universe is transparent enough, structured enough, energetic enough to be understood. When minds can arise that are curious rather than merely reactive. This alignment will not last forever. And yet, here it is. There is a temptation, when faced with cosmic scale, to retreat into insignificance. To say that nothing we do matters because galaxies do not care. But that conclusion misses something subtle. Meaning is not assigned by the universe. It is generated locally. A melody matters because someone hears it. A story matters because someone remembers it. Understanding matters because someone is changed by it. Andromeda does not care that we observe it. But the act of observation changes us. It stretches our sense of time. It softens the boundaries of the self. It reminds us that our problems, while real, are not the totality of existence. This does not make them disappear. It places them in a wider frame. In that frame, fear loosens its grip. Urgency becomes negotiable. Perspective returns. Perhaps this is one of the quiet roles of astronomy, not to make us feel small, but to make us feel situated. To remind us that we belong to something vast, ancient, and interconnected. We are not separate from the universe. We are an expression of it. The atoms in your body once drifted through interstellar space. They were part of clouds shaped by gravity, shocked by supernovae, enriched by dying stars. Some of them may have originated in galaxies long gone, dispersed before the Milky Way even existed. In a very real sense, your body is older than Earth. Andromeda, too, is built from recycled matter, generations of stars forming, dying, and returning their substance to the cosmic pool. Across space and time, the same processes repeat, sculpting structure from simplicity. Hydrogen becomes stars. Stars become elements. Elements become life. Life becomes awareness. And awareness looks back at the stars. This loop, matter becoming conscious of itself, may be rare. It may be fleeting. But while it exists, it is profound. When you next see Andromeda, you may not think of it as a distant galaxy anymore. You may think of it as a reminder that the universe is not only larger than we imagine, but older, deeper, and more patient than our anxieties. It does not rush. Neither should we. At least not always. Some moments are meant to be slow. Meant to be spacious. Meant to let the mind wander beyond schedules and expectations. Looking at Andromeda is one of those moments. A quiet pause in a loud world. A soft light from a distant past. A gentle suggestion that existence is bigger than any single story, including our own. And yet, without our stories, the universe would be silent. So we tell them. We look up. We wonder. We listen to ancient light. And for a brief moment in cosmic time, the universe is not just expanding. It is being understood. And even that understanding does not arrive all at once. It settles slowly, like dust after a long journey. When you step away from the sky and return to the world of walls and screens, Andromeda does not vanish. It lingers quietly in the background of thought, altering proportions in subtle ways. Deadlines feel a little less absolute. Conflicts feel a little less permanent. The idea of now stretches, gaining depth. This is not escapism. It is recalibration. Human life evolved for survival on small scales, immediate threats, short horizons, urgent decisions. But the mind is capable of more. It can step outside its evolutionary comfort zone and hold ideas that were never meant to fit easily inside it. A galaxy 2.5 million light-years away is one of those ideas. Not because it is useful, but because it is true. Truth, when encountered without filters, has a way of changing posture. It straightens some things, softens others. It does not tell us how to live, but it reshapes the context in which living happens. Andromeda does this quietly. It does not demand belief. It does not offer consolation. It simply exists. And existence, when vast enough, becomes instructive. Consider how patient gravity is. It does not hurry stars into orbit. It does not rush galaxies into collision. It applies the same gentle influence over unimaginable spans of time, confident that outcomes will emerge eventually. Human systems rarely work this way. We are impatient. We accelerate. We compress time until everything feels urgent, until the future feels like something to be conquered rather than approached. But the universe does not conquer time. It inhabits it. Andromeda has no anxiety about its future. It does not fear the merger to come. It does not mourn the collisions that shaped it. Each phase is simply another configuration of matter responding to the same fundamental laws. There is something quietly instructive in that neutrality. Not indifference, but acceptance. This does not mean humans should become passive or detached. Meaning is not found by imitating galaxies. Meaning is found by recognizing that struggle and transience are not failures of existence, but features of it. Even Andromeda bears scars. Its warped disk. Its asymmetrical arms. Its halo littered with the remains of consumed companions. Yet these scars are precisely what made it what it is. Without mergers, it would be smaller. Without disruption, it would be poorer in elements. Without loss, it would lack complexity. The same pattern appears everywhere, at every scale. Growth is rarely gentle. Stability is rarely permanent. Complexity is born from interaction. And this brings us back, inevitably, to ourselves. Human history is often told as a sequence of events, but it is more accurately a process, one shaped by pressures, collisions, and adaptations. Cultures merge. Ideas disrupt. Technologies reshape environments faster than biology can follow. From the inside, this feels chaotic. From a distance, it looks evolutionary. The difference between despair and perspective often lies in scale. When problems are framed as total, they crush. When framed as local, they become navigable. Andromeda does not trivialize human suffering, it contextualizes it, reminding us that no single moment contains the entire story. There will be other moments. There always are. The stars of Andromeda that shine tonight will not all shine tomorrow. Some will explode. Some will fade. Some will drift into new orbits, pulled by forces they cannot perceive. And yet, the galaxy persists. Not as a fixed object, but as a continuity of change. If there is a lesson hidden in that persistence, it is not that everything lasts, but that everything participates. Nothing exists in isolation. Your body exchanges atoms with the environment constantly. Your thoughts are shaped by language, culture, and biology. Your presence alters others in ways you may never know. Even this moment, listening, reading, reflecting, is part of a chain of causation stretching backward and forward in time. Andromeda is part of that chain too. Without it, our understanding of galaxies would be poorer. Our measurements of the universe less precise. Our sense of scale more fragile. It is a reference point. A cosmic anchor. A reminder that reality is not confined to what is immediately visible or immediately useful. There is more happening than we can track. More unfolding than we can control. More existing than we can fully comprehend. And that is not a flaw. It is an invitation. An invitation to humility. Without helplessness. To curiosity without entitlement. To meaning without permanence. When the story finally quiets, when the words run out and only silence remains, Andromeda continues its slow approach. It does not pause for reflection. It does not acknowledge attention. But attention matters anyway. Because in attending to it, in truly seeing it, we step outside the narrow corridor of the present and touch something vast enough to hold all our contradictions. Small, yet capable of wonder. Brief, yet capable of understanding. Fragile, yet able to look into deep time and recognize it as real. The universe does not promise answers. It offers context. And in that context, we are free to choose how we respond. To rush, or to pause. To narrow, or to expand. To treat existence as a problem to solve, or as a mystery to inhabit. Andromeda does not tell us which to choose. It simply waits, glowing softly in the dark, as it has for millions of years, a quiet companion to every generation that has ever looked up and asked, even silently, what else is out there? And sometimes, that question does not need an answer. It needs space. In a world saturated with explanations, predictions, and conclusions, there is value in leaving something unresolved, not because it is unknowable, but because knowing everything is not the same as understanding. Andromeda resists closure. You can learn its mass, chart its rotation, model its future. You can simulate its merger with the Milky Way down to the trajectories of individual stars. And yet, when you look at it with your own eyes, none of that information feels complete. A faint glow remains. A presence that is not fully captured by data or language. This gap between knowledge and experience is not a failure of science. It is a reminder that human understanding operates on multiple layers. Facts inform the mind. Experience reshapes the self. Andromeda does both. But in different ways. Intellectually, it expands our sense of scale. Emotionally, it quiets us. Existentially, it reframes our place. These effects unfold gradually, often long after the observation itself. Days later, you may find yourself thinking differently about time. About patience. About what deserves urgency and what does not. Not because Andromeda told you anything directly, but because it subtly altered the background against which your thoughts appear. Perspective is rarely loud. It works in the margins. Consider how rarely we question the pace of our lives. How easily we accept acceleration as progress. Faster communication. Faster production. Faster decisions. The assumption that speed equals improvement is so deeply embedded that slowing down can feel like failure. And yet, the universe does almost everything slowly. Stars take millions of years to form. Galaxies take billions of years to evolve. Even light, the fastest thing we know, requires patience to cross space. Nothing essential happens instantly. Complexity, whether cosmic or biological, requires time. Andromeda embodies this truth without effort. Its grandeur is not the result of sudden creation, but of accumulation, layer upon layer of history, interaction, and transformation. In that sense, it offers a counter-narrative to modern life. Not a rejection of progress, but a reminder that depth and speed are not the same thing. Some processes cannot be rushed without losing what makes them meaningful. Understanding is one of them. You cannot compress awe. You cannot optimize wonder. You cannot schedule insight. These things arrive when space is made for them. That is why Andromeda is best seen not through hurried glances, but through lingering attention. Through standing still long enough for the mind to settle into a rhythm closer to the cosmos than to the clock. This is not nostalgia for a simpler past. It is alignment with a larger tempo. One that existed before humans and will continue after us, regardless of our stories. And yet, stories matter. They are how we integrate vastness into meaning. How we translate scale into something the human mind can carry. Without stories, Andromeda would remain a blur, impressive, but distant. Through storytelling, it becomes a presence. Not anthropomorphized. Not romanticized. Beyond recognition. But situated within a narrative that connects stars to thoughts, galaxies to lives. This connection is not literal. It is relational. The universe does not revolve around us. But we are part of its unfolding. Our thoughts about it are themselves physical processes, neurons firing, atoms moving, energy transforming. When we think about Andromeda, the universe is, in a sense, reflecting on itself. That reflection is rare. Most of the universe is silent. Dark. Inert. In only a few places does matter organize itself into systems capable of curiosity. Capable of asking questions that have no immediate survival value. Capable of caring about distant galaxies. This capacity may not last forever. But while it exists, it is remarkable. Perhaps this is why looking at Andromeda feels different from looking at most things. It is not just an object. It is a meeting point, between light and time, between knowledge and humility. Between the finite and the vast. It does not overwhelm us because it is aggressive. It overwhelms us because it is patient. Patient enough to wait millions of years for its light to arrive. Patient enough to outlast civilizations. Patient enough to let us approach it slowly, in fragments of understanding. And in that patience, there is a quiet generosity. The universe does not owe us comprehensibility. And yet, it offers patterns, regularities, laws that can be discovered and shared. Andromeda follows those laws faithfully. It does not hide its structure out of malice. It reveals it gradually, to those willing to look long enough. This is not just a scientific process. It is a human one. We, too, are revealed gradually. To others. To ourselves. Over time. Through attention. Rushing obscures this process. Stillness reveals it. And so, in the final moments of this journey, there is nothing left to add. No new facts required. No conclusions to enforce. No lessons to summarize. Only an invitation to carry Andromeda with you, not as information, but as orientation. A distant galaxy that subtly changes how near things feel. A vast system that makes small moments more precise. A reminder that existence is larger than obligation. When you next look up, whether tonight or years from now, Andromeda will still be there. Unchanged in any way you can perceive. Waiting. And if you choose to notice it again, even briefly, you may find that it asks nothing of you except this. To look. To wonder. And to remember that you are living inside something far bigger than yourself, and still allowed to matter. And even that permission, to matter, does not arrive as a declaration. It arrives as a quiet allowance. You are allowed to care, even when the universe offers no guarantees. You are allowed to search for meaning, even when none is pre-written. You are allowed to pause, even when the world insists on momentum. Andromeda does not validate these choices. It simply does not contradict them. That, in itself, is powerful. Because much of human anxiety comes from the fear that our inner lives are somehow out of sync with reality, that reflection is indulgent, that wonder is impractical, that stillness is a luxury we cannot afford. But the cosmos is built on stillness. Between stars lie vast regions of near-perfect silence. Between galaxies stretch expanses so empty that even a single atom per cubic meter would be considered crowded. Most of existence is not activity. It is space. And from that space, structure emerges. Andromeda exists because gravity had room to work. Because time was not rushed. Because matter was allowed to drift, clump, collapse, and reorganize without interference. Life, too, requires room. Not just physical space, but mental space, intervals where thought is not immediately converted into action, where uncertainty is tolerated rather than eliminated. In this way, looking at Andromeda is not escapism from life. It is practice for it. Practice in holding complexity without panic. Practice in acknowledging scale without surrender. Practice in accepting that not everything meaningful is immediately measurable. The galaxy does not ask us to abandon our concerns. It asks us to situate them. A single human life is short. But it is not small. It is dense with experience, choice, and consequence. Within it unfold relationships, insights, failures, and transformations that matter deeply to those who live them. Andromeda does not erase that density. It frames it. It reminds us that intensity and duration are different dimensions. A moment can be brief and still carry enormous weight. A thought can last seconds and still alter the course of a life. Cosmic time does not invalidate human time. They coexist. This coexistence is easy to forget because modern life trains us to prioritize the immediate. Notifications demand attention. Metrics demand optimization. Outcomes demand justification. Andromeda demands nothing. It offers presence without pressure. That is why it has endured as an object of fascination across cultures and centuries. Long before telescopes, before equations, before scientific consensus, people noticed that small cloud in the sky and felt something shift. They did not know what it was. But they knew it mattered. Not because it affected crops or navigation or survival, but because it pointed beyond the ordinary. It hinted that reality was larger than the visible world. In every era, that hint has served the same function. It opens a door. Not to answers, but to perspective. Perspective is not passive. It shapes decisions in subtle ways. A person who has felt scale tends to choose differently. With more patience. With less certainty. With greater awareness of consequence. Not always better, but often wiser. And wisdom, unlike knowledge, cannot be accumulated endlessly. It must be integrated. Balanced against emotion, experience, and context. Andromeda contributes to that balance. It does not instruct us how to live. It reminds us that living is not confined to urgency. As this story stretches toward its final silence, there is one last thing worth noticing. The light from Andromeda that reaches your eyes tonight does not disappear after you see it. It is absorbed by your retina, converted into neural signals, processed by your brain. It becomes part of you. Not metaphorically. Physically. Energy that left a distant galaxy millions of years ago now participates in your perception, your thoughts, your memory. In that precise moment, a connection forms across space and time. This connection does not change Andromeda. But it changes you. And that may be the quietest, most understated miracle of all. The universe does not need witnesses. But witnesses exist anyway. And in witnessing, in looking up, in wondering, in allowing ourselves to be affected, we fulfill a role that is not assigned, but emergent. We become places where the cosmos notices itself. Briefly. Imperfectly. Subjectively. But genuinely. And when the night ends, and daylight returns, Andromeda will fade from view. The sky will empty. The ordinary world will resume its rhythms. Yet something remains. A recalibrated sense of proportion. A softened urgency. A memory of vastness that does not demand attention, but offers it. This is not an ending. It is a quiet return. Back to life, carrying with it the echo of something immense, not as burden, but as background. A reminder that while our days are finite, they unfold within a universe large enough to hold them. And that is enough. In the end, there is nothing left to explain. No final measurement that completes the picture. No last equation that closes the story. Because Andromeda was never a problem to be solved. It was an encounter. A meeting between a human mind and something so vast that it quietly loosens our grip on certainty. Something so old that it reframes what we mean by beginning and end. Something so distant that it reminds us how extraordinary it is to perceive anything at all. Andromeda does not resolve our questions about existence. It deepens them. It stretches them across time and space until they are no longer anxious demands for answers, but open invitations to reflect. We spend much of our lives inside small frames. Schedules. Expectations. Roles. Identities. These frames are necessary, but they are not complete. Without moments of expansion, they harden. They become prisons rather than structures. Andromeda breaks the frame gently. It does not shout. It does not insist. It simply waits, offering scale to anyone willing to look up and linger. In that lingering, something subtle happens. We remember that we are temporary, and that this is not a flaw. We remember that we are small, and that this does not make us insignificant. We remember that we are part of a universe that does not revolve around us, and yet has produced us. That contradiction is not a problem. It is the point. A universe that can give rise to galaxies like Andromeda, and also to minds capable of understanding them, is a universe where meaning does not have to be imposed from above. It emerges from within, from attention, from curiosity, from the courage to face scale without retreating into despair or arrogance. Andromeda will continue its slow approach long after our stories end. It will merge, transform, and move on, indifferent to who noticed it and who did not. But tonight, and in this moment, it mattered. It mattered because it expanded the space in which thought could move. It mattered because it reminded us that existence is larger than urgency. It mattered because, for a brief stretch of time, the universe was not only unfolding, it was being understood. That understanding does not need to last forever. Neither do we. It only needs to exist once, somewhere, sometime, for the universe to have known itself. Through us. And that is enough.